Hi guys, and welcome back to Physics Solution. Now, I'm super excited that you're back with me here. Today we'll be solving a question on the topic gas laws. And the question goes first. The work done by a gas when it expands to 8 times its initial volume of 0.5 times 10 to the power of negative 4 meter cube is 35.5 joules. At what constant pressure did the expansion occur? From the question, we realize that we're told that the initial volume of the gas is 0.5 times 10 to the power of negative 4 meter cube, and the work done is equals to 35.5 joules. So the work done by a gas when it expands to 8 times its initial volume. That means that the gas expands to 8 times its initial volume, which means that if the V1 is the 0.5 times 10 to the power of negative 4, then the V2, which is the final volume, will equals to 8 V1, 8 V1, and that will be 8 multiplied by 0.5 times 10 to the power of negative 4. When we use our calculator when you press the calculator, that will give us, that will be V2 will be equals to 4 multiplied by 10 to the power of negative 4 meter cube. So now, but we don't know what formula we're to use to solve this question first. And I think what we should do first is to derive a formula. And to derive the formula, we know that we are talking about work done here. And our work done is equals to force multiplied by distance. If that is the case, we have to solve for our force. So we know that from pressure equals to force over area. Now our force is equals to pressure multiplied by area. Okay, pressure equals to force equals to pressure multiplied by area. Let's call this our, okay, let me label this equation 1 and here equation 2. So let's put equation 2 into equation 1. So we have our work done equals to pressure multiplied by area multiplied by the distance. So we know that our distance is also a length. And remember, from our basic mathematics, we know that volume is equals to length times breadth times height. And our volume can also be equals to area times height. Height is also a distance, which is a vertical distance. So we can say that our work done is equals to pressure multiplied by, if we take this distance here as our height, therefore you can say area multiplied by d can give us the volume. So we have work done equals to pressure multiplied by volume. If that is the case, since we also know that the gas is expanding, the gas is expanding. When the gas is expanding, the volume is changing. Therefore, you can say our work done equals to pressure multiplied by this change in volume. By changing volume. This formula here is what we'll be utilizing to solve this question. Okay, I'll be solving the question this corner here. Now, we are given the work done to be 35. Okay, let me write the formula out again first. Our work done equals to pressure multiplied by the change in volume. Our work done is giving us 35.5 joules. equals to, but to solve for the pressure multiplied by the change in volume. Change in volume will be the V2 minus the V1. And the V2 here is 4 multiplied by the power of negative 4 minus the V1 0.5 multiplied by the power of negative 4. So you solve for that. But to find the constant pressure. So 35.5 equals to P multiplied by, we'll be having 0.00035, and this will give us 35.5 equals to 0.00035 P. So for P now, we divide both side by 0.00005. 0.00025. This will cancel this. So our pressure will be equals to 1.014 multiplied by 10 to the power of 3 Newton per meter square. 1.014 equal to meter per meter square. So I think this is the final answer for this question. I believe, and that will be all for this question. Endeavor to like the video if you've learned one or two things today, and also if you haven't subscribed to the channel, endeavor to subscribe. See you again. Let's confirm this now. This should be 5. This should be 5.